And the last time we look at all of this, and also going from the voltage source series with the resistor, we can change that into current source with the parallel in the resistor. We call source transformation, vice versa. And basically this left-hand side is going to be Thevenin circuit, right-hand side is the Norton. So last time when we work on the problem, we actually find both Norton and the Thevenin, right? Now let's do problem 538. First, find the VTH, and then since we are asked to find the I sub 0 go through 2K, we need to take that out, plus minus 12 volts, and we're gonna call it VTH, positive and negative, 1K plus Vx minus, this guy is a 2Vx. So this is plus Vx minus, this is 2Vx. So how we find the VTH? Any suggestions? Node where? Right there. Do we have really node there? This is the open circuit. So if I get rid of this guy, node is not there. We want to just find the voltage right here. Try that again. So if it's nothing in here, what do you want to do? Or there's only one mesh. It's not mesh analysis, what we call. Yeah. That's KVL, right? That's KVL. KVL. Then negative 12 plus, I'm gonna just call it I sub 1, 1 kilo I sub 1 plus 1 kilo I sub 1 plus 2Vx equals to 0. And from this equation, we have 2K I sub 1 plus 2Vx equals positive 12. We have two unknowns, I sub 1 and V sub x, right? So we should have another equation somewhere. Where? Aha. All right. The second equation is from here. So when you say 1 kilo times I sub 1 equals to Vx, now you plug in to that equation. We have 2K I sub 1 plus 2 times 1K I sub 1 equals 12. Now we have 4K I sub 1 equals 12. I sub 1 is 3 milliamp. Now we found I sub 1. How we find the VTH? Aha. We want to find the Vx first and then do KVL. Good, good, good. From here, Vx equals 3 volts. This is 3. And then KVL in here, negative 12 plus 3 plus VTH equals to 0. VTH equals 9 volts. What's the next? Find RTH. How do we find RTH? We're combining resistors. The same circuit, we took this 2K resistor out, then we're going to call it RTH right there. And what do we do with the independent voltage source? Turn it off. How? There are two ways to do that. The voltage, short circuit. And if we had the independent current source, we make it open circuit and then find the RTH. We have a problem. What is the problem? We have a dependent voltage source. So we cannot turn this off. So we cannot find RTH. But we do know last time we talked about Thevenin and Norton. We can change the Norton to Thevenin and Thevenin to Norton, right? So even if I ask you to find the Thevenin circuit, what you can do, we can put this back, find I sub n, Norton current, and then once you have a I sub n, RTH equals VTH over I of n. That's what we saw in the previous example. When we have dependent voltage source or dependent current source, we cannot find RTH just turning it off. If that is the case, we need to find I, Norton current. So how you find I sub n in here? Oh yeah. What's the value of Vx by looking at it? We don't have to even calculate anything. What's the value of Vx? Yeah, so 12. When you do the KVL in the first loop, negative 12 plus Vx equals to 0. KVL there, negative 12 plus Vx equals to 0. Vx equals to 12. That means this current is 12 over 1K. When we do KVL with the blue plus Vy minus, we have Vy plus 2Vx equals to 0. Vx we said 12. Vy equals 2 times 12 equals 0 plus. So Vy equals negative 24 volts. So this, put the polarity backwards, so it should be plus minus 24. That makes sense. Negative 24 plus 24 equals to 0. That means positive to negative, this guy is going to be what? 24 milli. This guy is going to be 12 milli. So I sub n equals 36 milliamp. Therefore, RTH equals 9 over 36 milli, so 0.25 kilo. So now we did both Thevenin and Norton together. So Thevenin circuit is going to be VTH equals 9, RTH is 0.25 kilo, and then Norton I sub n equals 36 milli, RTH 0.25 K. And in the original circuit, we took out 2 kilo, that was our load, and then current we want to find. For the top one, I sub 0 equals voltage 9 over sum of these two, 2.25 kilo amp. From the second one, I sub 0 equals, use the current division, opposite 0.25 K over sum of these two, 2.25 K, and then times the total current, 36 milli. Calculator, anybody? 4? Thank you.